For question 1, we're given a doghouse, which you can see on the diagram over here, and we know that it's 1.35 meters high, 0.9 meters wide, and also we know that this length over here is also 0.9 meters, and actually also a pretty important information is we know that it's made up of squares. So we know that this is a square, and also this will be a square, and that's why we know that this height will also be 0.9 and this will also be 0.9. So this is another pretty important piece of information, and we know that the top of the rectangular surfaces of the roof have to be painted. So basically rectangular surfaces will be this, and the same one on the other side. We cannot really see it on this drawing, but of course there will be two on both sides. I mean one on each side, so in total two. And we have to find the area to be painted. So basically we have to calculate the area of those two rectangles. So we know that this side will be 0.9. However, we don't know this side. So this is pretty much the only thing we actually have to calculate, because then we just multiply and we'll get the area. So now how would we do it? Well, we know that this has to be equal to 0.45. because it will just cut it in the middle. And we also know that this height over here will also be 0.45. So using the Pythagoras theorem, we can simply calculate this side over here, which maybe we can call it x, for example. So it will just be 0.45 squared plus 0.45 squared will be equal to x squared. So x will be equal to square root of 0.45 squared plus 0.45 squared. And this we can just plug into the GDC. So we have our GDC, and let's open the square root. So we had 0.45 squared plus 0.45 squared, and that's everything, right? Yeah, that's everything. So this is equal to 0.636, and this we can actually straight away, because this is just our x over here, so this we can just straight away multiply by 0.9, and this will give us the area of one of those rectangles. So this will be multiplied by 0.9. So this is equal to 0.5727, and so this is the area of one rectangle, so 0.5727, but we need two of them, so we just multiply this by 2. And this is our final area, so we can just say, for example, area paint, because it needs to be painted, was like 1.15, I think. 1.15, yeah, because we don't have any rounding. We don't, so it will just be 1.15. 1.15, 15, and this will be meters squared. And that's our answer to question 1. For question 2, we have a vertical pole which stands on the ground, and we know that it starts at the origin point. So the pole goes over here all the way up until the point F with those coordinates, and we know that there's a rope which is attached to the top of the pole, and it basically is then attached to the ground, which is at point A. And we know that point A has those coordinates. And for question 8, we have to find the length of the rope connecting A to F. So we're basically looking for this distance over here. And now how do we do it? Well, we simply have coordinates of both of these points, so we can use our formula, where AF will simply be equal to, and the formula is x1 minus x0 squared plus y1 minus y0 squared, and plus z1 minus z0 squared. So we just plug in our points. And so let's say our point A is our x1, so we'll just have 3.2 minus 0, which will just be 3.2 squared plus 4.5 squared, because again is minus 0, and this will just be minus 5.8 squared. So plus minus 5.8 squared. And this we can just plug into our GDC. So we'll have a square root again, and it will be 3.2 squared plus 4.5 squared and plus 5.8 squared. And this is equal to 8.01, and this minus just disappeared because we squared, so it will disappear anyway, so it's just equal to 8.01. And that's our answer to part A. For part B, we have to find the angle FAO, so I just named it alpha over here. And this is relatively simple, because we know that this side is equal to 8.01, and we also know that this one will be equal to 5.8, because this point is actually the origin. and the only coordinate difference between those 2 points is this 5.8, so that means that this height simply has to be equal to 5.8, and we can simply get our angle by calculating the sine, because we know that our sine of alpha has to be equal to 5.8 divided by 8.01. There's a point over here, and let's do that now with GC. So we just do sine minus 1 fraction 5.8 divided by 8.01, and the answer is 46.4. So that's our answer to question 2. For question 3, we have the height of a baseball after it is hit by a bat, and we know that is modeled by this function over here. And here t is just time in seconds, and h is the height. And for part A, we have to write down the height of the ball above the ground at the instant it is hit by the bat. So at the instant it is hit by the bat, it is simply when t is equal to 0. And so simply we have to plug t equals to 0 into our function. So this will become 0, this will also become 0, so this will just be equal to 1.2. So that's our answer to part A. For part B, we have to find the value of t when the ball hits the ground. So we have to find the value of t when basically our function will become 0, because the ball will hit the ground when the height will be equal to 0. So simply our function has to be equal to 0. And this let's find in our GDC. So let's type in our function. So we have minus 4.8 x squared plus 21 x plus 1.2 minus 41. Yeah, looks good. Okay, perfect. Yeah, so as you can see, this first 0 over here definitely won't count, because this is when t is equal to 0, and then this one will be the one that we're looking for, so there's no need to really adjust the window over here, because we just need to get the 0. So left bound, let's put it here, and right bound will be here. So t is equal to 4.43. And that's everything. So that's our answer to part B. For part C, we have to state an appropriate domain for t in this model. So let's actually check out the graph again to see what really happens here. So this is the function until the ball hits the ground for the first time, and then if we were to actually account for everything, all the other bounces, then we'll go somewhat like this. And of course, that's not the function. So the only appropriate domain for this specific function is between 0 and 4.43, because then other things will potentially happen to the ball after it hits the ground. But this we don't really know. We don't really have any model for this function. So this function only works until the ball hits the ground for the first time. So that's why the domain is simply between 0 and 4.43, because that's when it hits the ground for the first time. That's what we got in part B. So this is our answer to part C, and that's actually all for question 3. For question 4, we have 3 towns, A, B, and C, and we know that there's a road which is a perpendicular bisector to A and B. We have coordinates of A and B, and well, that's actually pretty much everything, because for part A we have to find the equation of the line for this road over here. So we simply have to find the equation of this line over here. And now how would we do it? Well, we know the coordinates of points A and B, so we can simply, first of all, we need to find the gradient between A and B, because then it's going to be perpendicular. The road is going to be perpendicular, so it will be relatively easy to get the gradient for the road. And then we'll also need a coordinate of 1 point on this line over here, but this we can get to in a second. So let's start with the gradient. So first, let's find the gradient of AB. So the gradient of AB will simply be equal to x2 minus x1 divided by y2 minus y1, which will be 6 minus 1 divided by x minus 6, which would just be equal to 7 divided by 14, which is equal to 1 over 2. So that's how we know that the gradient for the road, you can just call it road, will be -2, because we have to flip the fraction and also flip the sign, so it will just be -2. And also one more thing that we need is some point on our road. We have the point C, but we actually don't know its coordinates yet. But we know that this point over here will be in the middle between A and B. So we can just find simply we can find the midpoint, and the midpoint will be in the middle of those coordinates. So we need to find the midpoint, which will simply be -6 plus 8 divided by 2, and -1 plus 6 divided by 2. So it will be, so this will be just 2 divided by 2, which is 1, and this will be 5 divided by 2, which will be 2.5. So this will be our midpoint. So now we can actually get the equation for the line, which will be y minus y1 is equal to mx minus x1. So now we can plug in everything that we know. So we know that y1 will be equal to 2.5, equal to minus 2 x minus 1, and now we simply need to get the y. So y is equal to minus 2x plus 2 plus 2.5. Yeah, minus 2x plus 2 plus 2.5, yep. So y will be equal to minus 2x plus 4.5. So this will be our equation for this line, and this is our answer to part A. Now for part B, we know that town C is due north of town A, and we know that this road passes through town C. So this is actually what we can see over here. So basically what they tell us in the question is that C is basically directly north to from point A. So that's actually all the information that we have, and we have to find the y coordinate of town C. So from the fact that we know that basically from point A, if we go directly north, we'll be at point C. What that means is that our x coordinate will simply be the same, because we know that this coordinate over here simply won't change, because we'll just simply have a straight line over here. So we know that point C will have the x coordinate of minus 6, and the y coordinate is actually what we have to find. But we have the equation for the line, so we know that this equation for this line is equal to minus 2x plus 4.5. So now actually the only thing we really need to do to find the y coordinate is to plug this point minus 6, and we should get it pretty easily. So we'll just say y of 6 is equal to minus 2, well, minus 6 I think it was. Yeah, minus 6 is equal to minus 2 multiplied by minus 6 plus 4.5. So this is equal to 12 plus 4.5, which is 16.5. So this is the y coordinate of point C. For question 5, we're given the ticket prices for a concert, and we have 3 tickets types. So we have adult, child, and student, and we have prices for all of them, so 15, 10, and 12 Australian dollars. And we know that 600 tickets were sold. We know that the total amount of money, so the revenue generated from them, was $7,816. And we know that twice as many adult tickets were sold as there were twice as many adult tickets sold as child tickets. And we have to X has to be the number of adult tickets. Yep. X has to be adult tickets. Then we have Y will be child tickets, and Z will be student tickets. So for part A, we simply have to write down 3 equations that express the information given above. So how do we do it? Well, let's start with this piece of information, number 1. So we simply know that, so maybe we can also write here that, so this will be our X, this will be our Y, this will be our Z. So basically we know that 600 of them were sold, so simply X plus Y plus Z has to be equal to 600. So this will be our equation number 1. Then equation number 2, we know that the revenue generated was 7,816. So what that means is that, so the revenue is basically the number of tickets sold multiplied by the price. So the revenue generated from adult tickets, for example, only from adults, is 15 multiplied by X. Then we also need the revenue generated from child tickets, so it's 10 multiplied by Y, and finally 12 multiplied by Z, and this is equal to 7,816. So this is our equation number 2, and equation number 3 is that twice as many adult tickets were sold compared to child tickets. I cannot seem to be able to pronounce it properly. So basically we'll compare our X and Y's, and we know that there were twice as many adult as child. So if there was 1,000 adult, then there was 500 child. So for them to be equal, because we need some sort of an equal sign in an equation, then for them to be equal, basically we need 2 in front of Y. This may be a little bit counterintuitive, because we know that twice as many were sold for adults, so it would maybe seem that like this number should be multiplied by 2, but actually to make them equal, we know that Y has to be smaller, so there's less child tickets. We know that Y has to be smaller, so we simply have to multiply Y by 2 to make them equal. So yeah, these are our 3 equations. For part B, we simply have to find the number of each ticket that was sold, so we simply have to solve those simultaneous equations. So we go to our apps, we go to number 9, because here we have our simultaneous equation solver, and we have to select, so we have 3 equations and 3 unknowns. So actually that's the only thing we really need to do here. So in this case we don't really have to do anything. We just go to next. So next would be on top of your graph button over here. So just press graph now. And we simply have to write down the stuff that we have. So we have 1x plus 1y plus 1z is equal to 600. Then we have 15x plus 10y plus 12z is equal to 7,816. And okay, this will have to change a little bit because this is simply equal to x minus 2y is equal to 0, because this will be easier now, because now basically the only thing we really need to do is we have 1x and then we have minus 2y and we have 0z, and this is just equal to 0. And now we have solve over here, so again we press graph, and we have that x is equal to 308, y is equal to 154, and z is equal to 138. So this is our answer to part B. For question 6, we have a painting which is contained in a square frame, so this is the square frame over here, and we know that the painting has a shaded region which is bounded by the smooth curve and a horizontal line. So this is the smooth curve and this is the horizontal line, and we know the coordinates of the corners of the square, so -1 and 1 and 2 and 2, and we also know that the horizontal line can be modeled by the x-axis, so that this is our x-axis. And that's actually pretty much everything. And for part A, we have to use the trapezoidal rule to the values given in the table. So these are the values to approximate the area of the shaded region. So for part A, we have to simply implement our rule, so we just have a formula which is 1/2 multiplied by h, and then we have y0 plus yn plus 2, and then all the other y's over here. So the only thing missing here is our h, and the formula for h is just b minus a divided by n, where b is our highest x, a is our lowest x, and n is just the number of trapezoids that we can create. So this is actually a pretty interesting exercise for this, because always when you have an n amount of x coordinates, you will have n minus 1 trapezoids. So in this case, let's say that we had this -1 over here, then we had 0 over here, 1 over here, and 2 over here, so we have 4 points, these 4 points. Then if you were to draw those trapezoids, you would just have one here, then you have the second one over here, and the third one will be over here, because we have to connect them, so there will always be 1 point less. So that's why, and n is the number of trapezoids that we'll be creating, so that's why n is 3. So actually, if we were to plug all those values, we know that the highest x is 2, minus lowest x, which is -1, divided by our n, which we just found to be 3. So this is just equal to 3 divided by 3, so it's 1. So actually our h is 1, so we can kind of forget about it. So if we continue, this is just 1/2, and then y0, so 0.6 plus yn plus 0 plus 2, 1.2 plus 1.2. So this is just equal to 1/2, 0.6 plus, this will be 2.4, so 4.8. And this we can actually quickly calculate here, because it will be 1/2 multiplied by 5.4, so this will just be 2.7. So this is our answer to part A. For part B, we know that there was an equation used for this drawing, which is this one over here. And we have to find the exact area of the shaded region. So this we can just quickly do in our GDC. So we open our function and let's do a fraction. Let's do a fraction, and we'll have minus x to the power of 3 minus 3x squared plus 4x divided by 10. Oh no, there should be also plus 12 over here. Plus 12, and that's everything, so let's graph it. Okay, perfect. So it will probably be this part over here. So yeah, we have to find the exact area of the shaded region. So we know that the shaded region is between the points -1 and 2. So we just go to second calc, integral. So when you find the area, you always find the integral between -1 and 2. So our exact area is 2.925. So we'll have an integral between 1 and 2 of this. This was equal to 2.925 or something like that. 2.925, so actually 2.3. So this is our answer to part B. For part C, we have to find the area of the unshaded region in the painting. So if we go back, it's basically all of this over here. And this can be relatively easily done because simply if we find the formula for the square and we subtract the shader region that we have, then this will be exactly what we need. So we need to find the area of the square. And how do we do it? Well, we know that this side will have the length of 3. And how do we know that? Well, we know that definitely the x-coordinate over here will be the same as on the bottom. So this will be -1. And the y-coordinate has to be 2, as from this point. So that's how we can see that this distance, so the distance between the point -1 and 2 will of course be 3. And it will be the same here because we know that it's a square, or it can also be calculated in the exact same way. So we know that this will be 3. So we know that the area of the square is 3. Oh, I'm sorry, is 3 times 3, which is 9 meters squared. And we found the area of the shaded region here to be 9.925. This I had to delete. So actually maybe I can rewrite 9.25 meters squared. So the area of the unshaded will just be 9 minus 2.925. And let's just plug it into GDC real quickly. So we have 9 minus 9.925, which is equal to minus, of course, which is equal to 6.075 meters squared. And this is our answer to part C. For question 7, we have Leo, who is investigating whether a 6-sided die is fair. And to do that, he rolls it 60 times, and we have those observed frequencies over here. And, well, he carries a goodness of fit test with 5% significance level, so maybe I'll write here 5% significance level. And for part A, we have to write down the null and alternative hypothesis. So simply here, the null hypothesis is what we expect at first, and like you expect the die to be fair. So null hypothesis is that it is fair. So the die is fair. And so this is null hypothesis, and then we have the alternative hypothesis, which is that it is just the die is not fair. So that's just our answer to part A. For part B, we have to write down the degrees of freedom, and the degrees of freedom is simply equal to the number of groups that we have -1. And the number of groups is simply how many possibilities on the die we have. So we have 6. So the degrees of freedom, there's just simply 5 degrees of freedom. And that's our answer to part B. For part C, we have to write down the expected frequency of rolling a 1. So we had 60 throws, from what I remember. Yes, 60 times the die was rolled. And so we have 60 times. And if the die was fair, then the probability of rolling a 1 would just be 1/6. Would be 1/6. Because all of those probabilities should be the same, so they have to add up to 1. So we'll just have 60 multiplied by 1/6. Because we basically have to calculate the expected frequency, so the expected value would just be the number of throws multiplied by the probability, so this would just be 10. And this would be our answer to part C. For part D, we have to find the p-value for the test, so let's just do in our GDC. So we go to our stat, we go to edit, because we have to input those two lists. And for list 1, let's put in our observed frequencies. So in the goodness of fit test, we need the observed frequencies and expected frequencies. And if you don't really remember, you can also go here and just check. So you have goodness of fit, and as you can see, you have observed and expected. So let's fill them in. So let's go to stat, edit, and let's put our observed in L1. So observed is basically all of those frequencies over here. So 8, 7, 6, 15, 12, and 12. And for L2 we put expected. So expected is what we simply expect it to be if the die was fair. So then basically we had 60 throws. And actually in part C we calculated the expected frequency for if 1 was to be thrown, and it's 10. And it's actually the same for all of them, right? Because all of them need to have the same probability. So for all of them we just have 10. 10 and 10. And that's pretty much everything. Now we just go to stat, we go to tests. Again, we go to the goodness of fit test. And we have expected, yes, degrees of freedom is 5, which is actually what we calculated in part B. And we just do calculate. So the p-value is equal to 0.287. And that's our answer to part D. For part D, we have to write down the conclusion for this test. So when you have to write down the conclusion, you simply compare the p-value to our significance level, which was just 0.05. So as you can see, of course, 0.287 is much higher than 0.05, which means that there's insufficient evidence to reject the null hypothesis. So here just write insufficient evidence to reject the null hypothesis. And this is our answer to part E. For question 8, we have a factory which produces bags of sugar, and we know that they are normally distributed with a mean of 500 grams. So we can add grams over here, and a standard deviation of 3 grams. And for part A, we have to write down the percentage of bags that weigh more than 500 grams. So if you look at a normal distribution, so a normal distribution basically looks like this, and you have the mean over here. This is the mean, and the mean is 500 grams. And our question is to write down the percentage of bags that weigh more than 500 grams. So it's basically all of those over here. And that is 50% because they are symmetrical around the mean. So this is our mean, and all of those over here take up 50%. And on the other side as well, they take up 50%. So our percentage is 50. So the answer is 50%, and that's our answer to part A. For part B, we know that a bag that weighs less than 495 grams is rejected by the factory for being underweight, and we have to find the probability that a randomly chosen bag is rejected for being underweight. So we basically, again, we can draw a curve, our normal distribution curve, and we'll have our 500, our mean over here. And we know that all of them below 495, let's put 495 over here, all of them are classified as underweight and they are rejected. So basically this is 49, okay, maybe I can make an arrow, 495. So basically we care about this area over here. And this we have to calculate in our GDC, so let's do that. So we go to second, distributions, normal CDF, because we care about this whole area, not a specific point, so we do normal CDF. And our lower, so it can stay as this, you can put 0 because we don't have a lower boundary. Our upper boundary will be 495. Our mean is 500. And our standard deviation is 3. So this is our answer, it's 0.0478. 0.0478. And this is our answer to part B. For part C, we know that a bag that weighs more than k grams is rejected by the factory for being overweight, and the factory rejects 2% of those bags for being overweight. So again, we can draw the situation. So we have our normal distribution, we have our mean, and somewhere to the right there's some value k, above which those bags are classified as being overweight. So basically, above this k, they are all overweight, and we know that this area, so we know that the factory rejects 2% of those bags, so this area is simply equal to 0.02. And that's all we know, and we simply have to find the value of k. So to do that, we go to our GDC again, and in this case, we go to distributions again, and we'll be using inverse normal, because we know the area, because the area is just the 0.02. And now we fill in 500 as the mean, 3 as the standard deviation, and here in the tail we have to mark the tail, simply the tail that we're interested in. So in our case we're looking for everything above k, because from k above k they are classified as being overweight. So we care about the right tail, so that's why we mark right over here, and then we just do paste, and our answer is 506.16, but actually we don't have any rounding, so it will just be 506 to 3 significant figures, so our k will just be 506, and this will be our answer to question 8. For question 9, we have a function f of x which is equal to 2 divided by x plus 3x squared minus 3. And for part A, we have to find f prime of x, so we simply have to find the derivative. So to do that, maybe it would be best to just rewrite this function slightly, so it will be 2x power of minus 1 plus 3x squared minus 3. So from this, it should be fairly simple to get the derivative. So we just put the power in front, so it becomes minus 2x to the power of minus 2, because we have to decrease the power by 1, plus, again, we'll have 2 multiplied by 3x, we have to decrease the power, and 3 will just disappear, so we'll have minus 2x to the power of minus 2. This will be 2 plus 6x, and this will be our answer to part A. For part B, we have to find the equation of the normal to the curve f of x at point 1, 2. in some specific form. So basically we have this point 1, 2, and the form has to be ax plus by plus d equals to 0. And that's pretty much everything. So now how do we find the normal? Well, first we have to find, so basically normal is perpendicular to the tangent at this specific point. So we have to find the tangent at this point, and then we find the perpendicular line to this tangent, and this will be the equation for our normal. So now how do we find the tangent? Well, again, we have to find the derivative and put our x coordinate into our derivative. We already found the derivative, so we know that f prime of x is equal to minus 2x to the power of minus 2 plus 6x, and now we simply find f prime of 1 because we're looking for the tangent at point 1, and then we just put it in here, so we have minus 2, and this will be just 1 to the power of minus 2, so it will just be 1, and then plus 6, so it will be 4. So now we have our tangent, and now we have to find the perpendicular line to our tangent. And now how do we do it? Well, we simply have to flip this and also make it in this case into a fraction. So basically we can say, for example, gradient maybe m of our normal will be equal to minus 1 over 4, because the gradient of our tangent is simply equal to 4. So we have the gradient of our normal, and that's actually most of the things that we need, because we also know already the point, because the point will just be 1 and 2, because we know that it just has to cross at the point 1 and 2. So we have our equation for the line, which is equal to mx minus x1. So we just have y minus 2 is equal to minus 1 over 4 x minus 1. So we need this. Okay, we need to put everything on the left side. So let's do that in a second. So let's first multiply it out. So we have minus 1 over 4x plus 1 over 4. So let's put everything on the left side. Y minus 2 plus 1 over 4x minus 1 over 4. And this is equal to 0, and that's pretty much everything. So we just have now, it has to be in the form, so let's start with x, so it will be 1 over 4x plus y, and this will be minus 2 and 1 over 4, which is actually 9 over 4, and this is equal to 0. And let me just double check. But yeah, okay, so this will be, oh, actually, no, actually, there's a pretty important thing as well that needs to be noticed here, because in the question specifically, they say that a, b, and d are integers. And this is a pretty important part about this question, because here we don't only have integers, because we also have fractions. So basically what we have to do is we have to multiply everything by 4, and now we just have x plus 4y minus 9, which is equal to 0. And this is our final answer to part B. For question 10, we know that Carl has 3 brown socks and 4 black socks in his drawer, and he takes out 2 socks at random. And we have this tree diagram over here, and for part A we have to fill in the missing parts of the diagram. So as you can see, this is one missing part, and this is the second missing part. So we can just fill it in very quickly. So as we can see over here, the brown part is already filled in, and we only have to fill in what happens if he takes out the black sock first. And actually here we also need black and brown and black and brown. So if he takes out the black sock first, then basically what that means is that from the 4 black socks that he had, he will only have 3 left. So here we'll have 3, and this will be divided by 7 minus 1, because he already took 1 out, so he only has 6, not 7 left. This is black. So this is 3 over 6, and this, well, will also be 3 over 6, and that's because, well, they have to add up to 1, so this just has to be 3 over 6. So yeah, this is our answer to part A. For part B, we have to find the probability that Carl takes out 2 socks of the same color. So how can this happen? Well, it can happen if he takes out the brown sock first, and then in the second turn also the brown sock, or a black sock first, and then in the second turn also a black sock. So let's calculate the first situation, so 2 browns. So what will be the probability? Then the probability will just be 3 over 7. So this probability multiplied by this probability, so 2 over 6. And why do you multiply? Well, you multiply because always when you go within, so into the tree diagram, you multiply, and then as you will see in a second, when you go horizontally, so in this way, oh no, this is actually vertically. If you go vertically, then you add them up, and this I will show you in a second. So at first we multiply because we go within into the tree diagram. So this is just 6 divided by 42, which is just equal to 1 over 7. So this is the first situation of 2 brown. And then we have 2 black as well. And the probability of the first one being black is 4 over 7. And the second one being black is 3 over 6. So this is just 12 divided by 42. And we can, so this can be equal to, if we divide it by 6, so this is 2 and 7. So 2 over 7. And yeah, so these are basically our two probabilities. And now, since as I told you a second ago, when you go vertically, then you add them up. So we want to add up the probabilities of 2 socks being brown and 2 socks being black, because we simply care about the probability of taking out 2 socks of the same color. So it doesn't matter if it's brown or black. So basically, our final probability is just 1 divided by 7 plus 2 divided by 7, which is equal to 3 divided by 7. And this is our final answer to part B. For part C, we have that given that Carl has 2 socks of the same color, find the probability that he has 2 brown socks. So, in my opinion, it's always easiest to simply write it down like this. So we need the probability of, find the probability that he has 2 brown socks. So probability of 2 brown given, so always after the line you have given, given that Carl has 2 socks of the same color. 2 of same color. And this, if we wanted to use our formula, this is just P of 2 brown intersection 2 same color divided by P of 2 same color. And from the previous part, we actually found already that probability of 2 socks of the same color is 3 over 7. So here we can just put 3 over 7. And here on top, we need the probability of 2 socks being brown and also them being 2 of the same color. So actually, this is basically just this probability, because the only intersection of 2 of the same color and 2 brown is just 2 brown, because, well, 2 of the same color is also 2 blacks, 2 black socks, but 2 brown will not be a part of this, right? So we need the intersection. So the only intersection here will simply be 2 brown socks. So we'll actually have 1 over 7 divided by 3 over 7. So this will simplify it nicely, because we'll just have 1 over 7 divided by 3 over 7, which is equal to 1 over 7 multiplied by 7 over 3. They will cancel out, and we'll just have 1 over 3. So this is our answer to part C. For question 11, we know that the strength of earthquakes is measured on the Richter scale with values between 0 and 8, and we have this equation which is used to calculate it, and the equation is given here, so it's log with a base of 10 of n is equal to a minus m, and we know that n is the number of earthquakes per year, so here we can add per year, and m is the magnitude. And that's pretty much everything. And for part A, we know that there is a particular region which has an average of 100 earthquakes per year with a magnitude of at least 3. And we have to find A. So this A over here. So we can simply plug in the information that we know. So we have log 10 of, and we know that the region has an average of 100 earthquakes per year. So this is our n. So we can just put this over here, because we know that there's 100 earthquakes, and this is equal to A minus, and we know the magnitude with a magnitude of at least 3. So m is 3. And now we simply have to find A. So now how do we do it? Well, from this we can deduce that 10 to the power of A minus 3 is equal to 100. So A is simply equal to 5, because then if A is equal to 5, then we have 5 minus 3, which is equal to 2, so we have 10 to the power of 2, which is 100. So A is equal to 5, or also the way you could do it is you could just simply write it as A minus 3 is equal to 10 to the power of 2. So now you have the same basis, and you can just equalize the powers. So A minus 3 is equal to 2, so A is equal to 5 to 5. And it's the same answer, of course. So A equals to 5 is our answer to part A. For part B, we also know that the equation for this region can be written as n equals to b divided by 10 to the power of m. So this is what you can see here, and we have to find the value of b. So maybe let's rewrite this log that we had on top with the value for a that we know. So we know that it will just be log 10 n is equal to 5 minus m. Okay, and let me just see. Yeah, but okay, that's everything that we know. Okay, so now let's rewrite it again in this form that we had over here. So this will just be 10 to the power of 5 minus m. Yep. is equal to n. Okay, so now we have it as n equals to something, which is a good start. And now we simply have to make it such that we have it as a fraction. So in this form. So actually this we can slightly rewrite because we know that this will simply be 10 to the power of 5 divided by 10 to the power of m, because that's then you just subtract powers. So this is equal to n. So actually this is equal to, so n, we can write it as n is equal to 10 to the power of 5 divided by 10 to the power of m. And yeah, that's actually pretty much everything, because this is our form. So we have to find the value of b. So of course this is just our b, because here we just have 10 to the power of m, which is exactly what we need to have. So our b is simply equal to 10 to the power of 5, or you can just write it as 1 and 5 zeros. And this will be our answer to part B. For part C, we have that given that m is between 0 and 8, we have to find the range for n. So we simply have to find the possible values for n. So our n, we can write the formula from the top. We have b divided by 10 to the power of m. 10 to the power of m. And yeah, and now I actually found this b over here. So we can write it as 1 and 5 zeros. I don't know if that's the best form, but actually it was 5. Let's stick to it, and maybe we'll change it later. Divided by 10 to the power of m. So now let's plug in 2 by 10 to the power of m. So now let's plug in the highest value for m and the lowest value for m. Here, since m has to be greater than 0, actually it doesn't really matter. You can just plug in that m is equal to 0, because then for n you will also have the brackets which are not including those numbers. I'll actually show you in a second. So let's assume that the smallest value for m is m equals to 0. So then for that, n will be equal to 1 and 5 zeros divided by 10 to the power of 0, which is just 1. So that means that this is just 1 and 5 zeros. And if the highest value for m was 8, then our n is just equal to, let's just put this as 10 to the power of 5 divided by 10 to the power of 8. Actually, this is also changed as 10 to the power of 5. So this is to the power of 8, not 108. So this is just equal to 10 to the power of minus 3. So we have our the lowest possible value for n and the highest possible value for n. So this is the lowest, this is the highest. And now when you write the range, what you can do is you simply write it as this, as 10 to the power of 5. And that's why you were using m equals to 0 and m equals to 8 as the highest and lowest possible values for m, because now when you get those values, then of course you also just simply don't include them, and you get your range like this. So this is our answer to part C. For part D, we know that the expected length of time in years between earthquakes with a magnitude of at least m is 1 over n. And within this region, we know that the most severe earthquake recorded has a magnitude of 7.2. And we have to find the expected length of time between this earthquake and the next earthquake of at least this magnitude. So now how do we do it? We know that, so we're simply basically looking for this time. We know that the expected length of time is given by this formula over here, so 1 over n. And yeah, we simply have to find the length of time between this earthquake and the next one of the same magnitude. So now how do we do it? Well, we simply have to find 1 over n somehow. Well, from part D we don't really have anything about it, but actually in part C we had this, which is quite useful, because simply we can calculate n like this. So let's do that. So n is equal to b, we know, which is 10 to the power of 5, and this 10 to the power of m, we know that m is equal to 7.2. So we can simply write it as 10 to the power of 5 divided by 10 to the power of 7.2, which is equal to 10 to the power of minus 2.2. And this we can plug in our GDC, and we'll get the value for n, and then we plug it into here, and we should get our answer. So let's do that. So let's go to our GDC. And so we had 10 to the power of minus 2.2. So this is equal to 0.063, and actually we don't really have to take it yet, as in like we could potentially write it down, but actually now to get the final answer, because now we found the value for n, so we know that this is like 0.006 something, and now to get the final answer we have to calculate simply 1 over n. So we can go back to our GDC, and basically what we do is we just do 1 divided by, and we take our answer. So this is our answer, 158.49. And this is the value in years. Yes, in years. So this is years. and we have to find given to the nearest year. So the nearest year is 158, so the final answer is 158 years. And this is our answer to part D. For question 12, we know that a company's profit per year is changing at a rate of 3t squared minus 8t, and p is our profit and t is the time and years since the company was founded. And for part A, we have to determine whether the profit is increasing or decreasing when t equals to 2. So t equals to 2, and we have to find whether profits are increasing or decreasing. And now how do we do it? Well, the way you check if a function is increasing or decreasing is that you simply find the derivative of this function, and then you plug the point which you're interested in into this derivative, and then if the value is negative, then this means that it's decreasing. If it's positive, then it's simply increasing. So we simply plug in our value, and we will have that 3 multiplied by t squared, so it will be by 4 minus 8 multiplied by 2. So this is just 12 minus 16, which is minus 4. So as you can see, minus 4, of course, is smaller than 0. And yeah, and that means that it's decreasing. And this is our answer to part A. For question 12, we know that 1 year after the company was founded, the profit was $4,000. So 1 year, so t is equal to 1, because t is the time since the company was founded, and p is the company's profit in thousands, so p is equal to 4, because we know that the profit was $4,000 1 year after it was founded, and we have to find pt. So now how do we do it? Well, we have to find the integral, so we have to integrate our derivative to get our normal function. So we simply do 3t squared minus 8t dt. So this is equal to, we have to raise the power and divide it by the new power. So we have 3t, so t squared becomes t to the power of 3 divided by 3. And then we have minus 8t squared divided by 2. And then plus c, we have some constant which we'll have to get in a second. So this we can simplify a little bit. So this will just be equal to t to the power of 3 minus 4t squared plus c. So this is almost our answer, and now we simply have to plug in this point to get our c. So this basically means that p is equal to p of t is equal to t to the power of 3 minus 4t squared plus c. And now we simply plug in these 2 points, so we know that p is equal to 4, so we have 4 is equal to, and now t is equal to 1, so we have 1 to the power of 3, so 1 minus 4 plus c. So yeah, so we have 4 is equal to minus 3 plus c, so c is equal to 7. So our final answer is that pt is equal to t to the power of 3 minus 4t squared plus 7, and that's our answer to part B. For question 13, we know that a ball is dropped from a height of 1.8 meters and then it bounces from the ground. And we know that the maximum height reached by the ball after each bounce is 85% of the previous maximum height. So simply, so this is 1.8, all the way to here is 1.8. And then this means that this second height will simply be 1.8 multiplied by 0.85. Okay, you cannot really see it here, but maybe I can write it here. 1.8 multiplied by 0.85, so this will be our second height, and so on and so on. For part A, we have to show that the maximum height reached by the ball after it has bounced for the 6th time is 68 centimeters. So this is the first bounce, so after the first bounce it will be at the height of 1.8 multiplied by 0.85, and we have to show that after the 6th bounce it will be 68 centimeters. So now how do we do it? Well, we simply have to we have to first recognize that this is going to be a geometric series, and we'll have the first bounce over here, then we'll have the second bounce over here, second bounce, and for that the maximum height will just be 1.8 multiplied by 0.85, again multiplied by 0.85. So as you can probably see already from here, this will just be 1.8 multiplied by 0.85 to the power of 2, and this is just 1.8 multiplied by 0.85 to the power of 1. So as you can see, the power is simply the bounce that we have. So if we had the third bounce, it would just be 0.85 to the power of 3. So we simply have to calculate 1.8 multiplied by 0.85 to the power of 6, or actually even better, it will be to convert it to centimeters because our answer asks for centimeters. So it would just be 180 multiplied by 0.85, not 6, to the power of 6. And this will be our answer in centimeters, so let's plug it into GDC and let's see. So we have 180 multiplied by 0.85 to the power of 6. And as you can see, it's 67.88, and it has to be rounded to the nearest centimeter, so it's just 68 centimeters. So it's 67.8, was it 88? 89 actually, 89, which is 68 centimeters, right, rounded to the nearest centimeter. So this is our answer to part A. For part B, we have to find the number of times after the first bounce that the maximum height reached is greater than 10 centimeters. So again, we can continue drawing it here, but basically we have some height. We actually found it for the sixth bounce, so I think it's even here. We found that this height at the sixth bounce was 68, and we have to find how many bounces there will be so that the maximum height is bigger than 10. So we get this 10 over here, and this has to be the maximum height. So we have to slightly rearrange the equation that we have. So in general, the general form that we have is that 180 multiplied by 0.85 to the power of the bounce, and now we don't know that, so let's call it just n. And this is equal to the greatest height. So now we simply need the greatest height to be greater than 0.1. So this simply has to be bigger than 0.1. Actually, no, this has to be bigger than, I mean, either you put it as 1.8 and greater than 0.1, or you do 180 multiplied by 0.85 the power of n, and this has to be greater than 10. So this is simply the equation we have to solve, and well, this we can solve in our GDC. So maybe let's rearrange it. Let's do 180 multiplied by, actually it doesn't really matter, we can just put two functions. So I usually do it in the first way, I mean in the way that I wanted to show you, but actually it doesn't really matter. So let's do it in the second way. Let's just clear everything here. So we have two functions. We have 180 multiplied by 0.85 to the power of x, so x becomes our n, and the second function will simply be 10, because this will just be a straight line, and we'll be looking for the place at which they intersect, but our the first function will have to be above the second function. So let's see what we get. Okay, so we definitely need to change the window. So let's put, for example, minus 30 and 30, and here as well. And let's see what happens now. Okay, perfect. So as you can see, this is of course our second function, so simply that y is equal to 10, and this is our first function, so 180 multiplied by 0.85 to the power of n, and we're looking for this intersection. Intersect. This should find it pretty easily. So as you can see, the intersection is 17.78. So n is 17.78, and now we have to see what are we really looking for, because at the point 1778, so basically at the 17th bounce, it will still be okay, because we care about the parts which are, so our first curve, so our blue curve has to be above the red curve, and this is of course before the 17.78. So our value, the latest value that we can take is 17, because if we, of course, like, you cannot have like your bounce cannot be like a 17.3, so your bounces have to be integers. So the two possibilities, let's say, that I guess we would be thinking about is 17 or 18. And now 17 has to be the value that we take here, because when you go to 18, then 18 will be already when our blue curve is below our red line. So n equals to 17 is actually the answer that we care about here. So this is our final answer to part B. For part C, we have to find the total vertical distance traveled by the ball from the point at which it was dropped until the fourth bounce. So maybe I'll sketch it again, just a rough quick sketch. So we had the initial height where the ball was here, the initial height was 1.8, and then it was dropped for the first time. So we had the first bounce over here, then we have ball here, second bounce, third, okay, it should be a little bit lower, but should be fine, and the last bounce is fourth over here. So we have something like this. So of course here we just have to recognize that this is a geometric series because we have to calculate the total distance, but we'll have to double them, which I will show you in a second. So for now, let's not double them, and let's just see what we get. So we have the sum of the geometric series. So the sum of the geometric series will have 4 terms over here because we go 1, 2, 3, 4. So we have 4 terms, and the formula is just u1 multiplied by 1 r to the power of n divided by 1 minus r. So u1 is 1.8 multiplied by 1 minus 0.85 to the power of 4 divided by 1 minus r, 1 minus 0.85. So let's throw that in the GDC. So we have a fraction, and we'll have 1.8 multiplied by 1 minus 0.85 to the power of 4, and this will be divided by 1 minus 0.85. Yeah, looks good. So we have 5.735, but we actually use this, probably use this answer in a second. So as I told you a second ago, we'll have to multiply it by 2. Why? Because every height, as you can see, apart from the first one, which we'll get to in a second, every height, so this height happens once, and then the ball has to go back down. So this height happens twice. Then the third height also goes up, and then has to go back down. So this also happens twice. And as you can see, all of these heights will happen twice, apart from the first one, because the first one is already on the top, so it doesn't have to reach the top, let's say. So actually all of these heights will have to be multiplied by 2 apart from the first one. So what we can do is we can simply multiply this 5.735 by 2 and subtract 1.8. And this will be our final answer to this. So let's do that in the GDC because we can just use the answer that we had. So let's just take this and let's multiply this by 2 and do minus 1.8. So the answer is 9.67. 9.67. And yeah, we don't have any rounding here, so this will be meters. And this is our answer to part C.